Today we will discuss about domestic wiring. Wiring done in domestic premises for providing electrical power for fans, lighting and domestic appliances are called as domestic wiring. It is done for the domestic purpose. It is for the household fans, lighting and other domestic appliances are called as domestic wiring. The factors to be considered while doing wiring: durability. It has to be durable. So while doing wiring, so it has to be very durable. It has to be safe. Safety you have to consider. Appearance, how it looks while doing wiring or after doing wiring, how it looks, that also matters. Switch closed accessibility. So while providing some switch, so how much it is closed, how much we can approach it to operate it, that is also important. Maintenance cost, overall cost. So everything we need to consider while doing wiring. Service mains. What is meant by service mains? Generally a cable which connects the distributor to the consumer terminals. So one cable which is coming from distributor to the consumer terminals, it is called service mains. Uh, Usually it is a wire which is run from very nearby our house, one electrical pole, to our meter board. It is called service mains. A wire which is running from an electrical pole which is very near to our house to our meter board is called service mains. It mainly consists of conductors which are of a few meters long that run from pole to the consumer premises. For single phase supply, two wires are used. One is phase and the other one is neutral. There are two types of service mains. One is overhead service mains. Second one is underground service mains. So what is the specifications? What is meant by overhead service mains? We will see. In overhead service mains, the wires are connected from electrical pole to the meter board. Fine. These overhead service connections is taken with the help of PVC or weatherproof cables. Next, the GA wires are run parallel to these for mechanical support. Then how it looks? So this is overhead service mains. So this is a electrical pole very near to the house. If you take this as the house or destination, so this is the electrical pole. It is a distributor side. So electrical pole. So from this up to this electrical pole, electrical connections are coming from substations of our city. So from the substations, one service main, it is running from this pole to the meter board of this house. So it is called service mains. Actually it is of two wires. One is a phase, one is neutral. The third wire is called the supporting wire. It is called GI wire, galvanized iron wire. It is used to support, so these two phase and neutral. Always the two wires are running. One is phase and neutrals. The third one is the supporting wire, so which is running along with these two wires, so to give support to this phase and neutral and next to the meter board. Next is the underground service mains. It is preferred when obstructions such as buildings, trees, large sized moving vehicles, etc. if it is there, so we cannot run the overhead service mains. So in that situation we are going for underground service mains. Next, overcrowding of overhead lines. If there are so many cables are running on the overhead lines, just like this, if there are bunch of service mains, overhead service mains, if there is no place for do any other further extension of these service mains, then we need to go for underground service mains. Next, aesthetic point of view, how it looks. If it is so many overhead service mains that if it is not looking good, it is looking very ugly. Aesthetic point of view, we need to go for underground service mains. The disadvantage of this underground service mains are cost is very high because we need to lay underground, so inconvenience for future excavation of earth. So if they want to do any future work on earth, so very difficult for us, so because it is laying underground, that much area we need to leave, and there may be some problem for the future extension of if you do any earthing, if you do any work in the earth. So there is a problem. So this is the example of underground subsystem. Once again, here cable is run from the nearby pole to the meter board. It is called meter board. So this is a house. So meter board is situated outside the house and is coming from a pole, electrical pole. Two wires are running. So here two wires are coming. So here through the J pipe, when it is attached to the poles, and when it is running, so very parallel to the poles, it is through GI pipe. One GI pipe it will be run. So inside the GI pipe, these wires it has to be run, and it is coming to underground. So many things that has to be done. Then while coming very near to the meter, once again there is a GI pipe to the up to the meter board. Then it is giving connection to the meter board. Saddles are used to clamp these GI pipes. Here also some saddles are used. And how to lay these underground cables, these underground service mains. So there are very deep. There is a cable. So it has run. So over to that there is a cement concrete, sand it has been put. So over to that sand. So cables it has done. So this cable can be run through J pipe only. So inside the sand, I mean inside ground, underground. So this cable are run through the J pipes once again, and over to that sand has been put. So bricks has been put. After that cement concrete it has to be put. Then it has to be done ground level. So many things it has to be done for underground system, underground service main system. So but it looks very neat, but is very, very costly. Our purpose is to run a service mains from the electrical pole to the meter board of our house. There is a meter board and distribution board. How the wiring looks like. So it is coming from a nearby pole. I told the service mains or transformer very near to house. From the pole, the two wires are coming to the meter board. From this meter board, so from this meter board, it is going to the our inside house meter board. It is called inside house distribution box. Inside house distribution box. Inside there is a DPMCB, double pole miniature circuit breaker will be there. So from this miniature circuit breaker is a main switch. It is called as main switch of our house. From meter board it goes to main switch DPMCB. From this DPMCB it goes to, one is neutral, second one is the phase. So all phases are connected to the switches, respective switches. It may be lighting switch or it may be AEH switch. So this is the distribution. So the neutral is made common. Neutral is made common, and phase, one phase is going to all the switches. So in any switch there is no phase neutral, only phase is running, because while you putting on and off, the phase will break down or it will connect. So when you switch on, so this will connect, common neutral will act. When you switch off, so this will disconnect, the electrical supply will disconnect. That's all. The wiring system. A network of wires connecting various accessories for distribution of electrical energy from the supplier meter board to the numerous electrical energy consuming devices such as lamps, fans, etc. through controlling and safety devices is known as wiring system. A network of wires, it is a wiring system, is a network of wires which connecting various accessories. So what you're using our accessories of electrical energy from the supplier meter board to the numerous electrical energy consuming devices. From electrical board to the lamps, fans, lighting arrangements or washing machines or fridge, any appliances what you're using, through controlling and safety devices. That is very important. Through our meter board, through our main switch, is the controlling and safety devices is known as, totally it is called as wiring system. The types of wiring system, depending upon the application, there are various types of wiring systems. One is the conduit wiring, TRS wiring, PVC wiring, cleat wiring. So these wirings are Now, not is that much popular right now, so only conduit wiring that we'll see. So this is the PVC wiring and casing capping. So before olden days they used to have PVC wiring and casing capping wiring, cleat wiring. So cleat wiring also now they are not using. This is an open type of wiring. So wiring will be all visible on the walls. It is not all using right now. So we are concentrating on conduit wiring now. The conduit wiring, metallic tubes called as conduits are to be run on wires, run on the wires. It gives full mechanical protection to the wires. It is desirable for workshop and public buildings. So conduit wiring. Depending on whether the conduits are laid inside the walls or supported on the walls, there are two types of conduit wiring. So this is called conduit wiring. So this is also called as conduit wiring. There are two types: surface conduit wiring and known as concealed conduit wiring. So this has been given: surface conduit wiring and concealed conduit wiring. Metallic tubes called as conduits are run here. So so this is called metallic wires. It is called surface conduit wires. So here metallic tubes are used inside this conductors are run. The wires, so-called wires, are run inside these metallic tubes. So it has been run on the surface of the wall, so it is called as surface conduit wiring. Here the metallic tubes, which are called as conduits. In the technical word, on the wiring system, it is called as conduits. Inside this wires have been run. Since it has been mounted on the walls, it is visible on the surface of the wall. It is called as surface conduit wiring. It gives full mechanical protection to the wires. These conduits what you are using, so it gives full mechanical support because the wires are run inside this conduit. Depending upon whether conduits are laid inside the wall or supported on the wall, it's called this is called inside the wall. So these conduits are run inside the wall while doing construction of house. So what these electricians or electrical contractors doing is while constructing the house, they are chipping the wall. Once the wall has been done, they are chipping the wall and they are laying the cables or conduits inside the wall by gluing it. Then once the wiring has been done, the plastering work will be done. Over to the cementing work will be done. Over to that painting will be done, so that no conduits or wiring is visible. So this kind of concealed conduit wiring are doing nowadays because of the aesthetic point of view, because of the good looking point of view. Otherwise, in the previous olden days, this kind of wiring system, it has been done, it will be visible outside, it not looks nice nowadays. So they are going for concealed conduit wiring right now. See the point is the concealed conduit wiring. The conduits are made up of mild steel. Yes, it is. Actually it has to be mild steel. Nowadays they may use hard PVC conduits. The standard length of each conduit may be of 4 meters. One length. If you ask and go and ask in the hardware shop, you give the conduit. They will ask you how much length conduit you want. Actually, one length means 4 meters, nearly 4 meters. Based on the outer diameter, various size conduits from 12 mm to 63 mm are available. So if you see the diameter of a conduit, it is varies from size to size. 12 mm to 63 mm, the diameter conduits are available. The conduits are to be erected completely before laying any cable in it. So what they used to do is first of all they are laying these conduits. So you can see there are no wires here. First the conduits are laying inside the walls. Then they are running the cables inside the conduits. The so-called electricians. So they are penetrating or they are inserting the cables inside these conduits. And they are dragging it from one side and the cables will come. The rigid conduits are always terminated at outlets into a box, which may be round, square or octagonal. The rigid conduits are always terminated at outlets into the box. So this is called box. It may be rectangular or square. So rigid conduits, it has to be terminated here. These boxes are used to provide connections for lights, fans, heaters are called as outlet boxes. So these are called outlet boxes. So these are used to give connections for lights, fans, heaters are called outlet boxes. Inspection boxes are used to facilitate the pulling of conductors, while junction boxes are used to house the junctions of the conductors. So there are two types of boxes. One is inspection box, second one is junction box. Inspection box are used to facilitate the pulling of conductors. So there are two types of boxes. One is junction box, the second one is inspection box. Though in some places they are putting in between inspection boxes just to pull the conductors. So very difficult to run very long conductors to make it a cut service. So what they should do is they will provide small boxes, junction box here, junction box in some other places, and they are cutting the conduits, and once again they are giving connection to the boxes. Advantages of this concealed conduit wiring. The beauty of premises is maintained definitely because it is not visible outside. It is completely concealed. It is durable. It has got very long life. It requires very less maintenance once it has been inside the walls. So not necessary to take maintenance over that. Very little maintenance is enough. Damaged wires, if any, can be replaced easily. So through this it is called as inspection boxes. It is used to pulling of conductors. They are placing inspection boxes as well as junction boxes. So through this inspection boxes, if wires has been damaged, so what they should do is they will, from that boxes which are situated, from there only they will pull the conductors, they will remove it and rewire it. It protects the wire from mechanical shocks, moisture and fire hazards. Proper earthing of conduits makes the method electrical shock proof. That is very important. Earthing, it has to be done very properly, then it is very good electrical shock proof wiring system. Some disadvantages are also there. The repairs are very difficult in the case of concealed conduit wiring because inside any wires have been damaged. If you want to remove the conduits, it is very difficult. The conduits have been damaged, if any. This method is most costly and the erection requires highly skilled laborers. Unless in the open system wiring, surface conduit wiring, because it can be done by any electrician, so without that much skill is required for that, because it can be run over the surface of the wall. But here in a concealed conduit wiring, it is somewhat costly and erection requires highly skilled laborers. They should know how to do it, where to do it, how to place the junction box, where to place the boxes. Keeping conduit at the earth potential is must. Without proper earthing, there is a danger of electric shocks. If manufacturing conduit is not proper, then sharp edges of the metal conduits can cause damage of the insulation of the wires. So one more disadvantage is we are using some of the conduit system. So if the conduit which has been brought, it has got some sharp edges, it may damage the wires. We may not be knowing, and at the end, continuously, if it rubs the wires, its insulation may break down, electric shock may occur at the end. So that I have to take care. There is a disadvantage of this method. The comparison between surface and concealed conduit wiring. So surface conduit wiring, already seen, there is a fixed to the wall, and concealed is buried under the plaster. Is a plastering, it has been done. Surface conduit wiring, conduit is fixed by means of saddles. Saddles is a clamp, so it is called as saddles to the conduit, which has to be formed to the walls. They are fixed by means of J hooks. So here is some J hooks are there. So it is called J hooks, so which can be used for the concealed type of wiring to fix this on the walls. It's called J hooks. Some of the J hooks here and there, what you are using here. It is not fully protected from mechanical injury because it is open, quite open. But here the concealed conduit wiring, it is fully protected from mechanical injury. Surface conduit wiring is cheaper compared to concealed. Concealed wiring are very costlier. surface conduit wiring has got some bad appearance because it has been seen outside. It's not looks good, but concealed conduit wiring nowadays it goes very good appearance. And here the surface conduit wiring for the wiring system, wherever you want to bend the cables, you have to use bends and T's and elbows. So T's, there is one structure called a PVC structure called T structure, as well as elbows are available. That is, elbows are around 90 degree. So bend structures it is available. If you want, you can go to hardware and you can check. So T's and elbows, here only bends are used. In concealed conduit wiring the bends are used. Next topic is two-way and three-way control of lamps. Out of that is a two-way control of lamp. So two-way control of lamps are used where there will be two switches which will control one light. So how it has been done, it can be shown by this. If L1 and L1 are connected, you can observe the lamp when it is glowing actually. So when L1 and L1 are connected, so it will have a closed circuit, the lamp will glow. See here the second option, if L1 and L2 are connected, so that means to say if both switches, how it operates. So that's the meaning of this. When switches one is on, one is off, or both are on. So if both are making it on, it may not work, because it may not give the closed path for the lamp to glow. So if you connect L2 and L2, so lamp may glow. And if you connect L2 and L1, once again it will not get the closed circuit, lamp may not go. This is the way of operating two-way control of lamp. It can be used in the staircase system actually mainly, or bedrooms, or any other main halls. They are using this kind of two-way control of lamps, where one lamp can be controlled by two switches. So the tabular representation, so how it works: L1 L1 on, L1 L2 off, L2 L1 off, and L2 L2 on. So this is a representation of two-way control of lamp. So that already seen in your lab. So next comes the three-way control of lamp. Here one lamp is controlled by three switches. So how it is possible now? So intermediate switch, what you are using is a double pole double through intermediate switch, and this switch here it is a single pole double through. So a single pole it can throw in two places, so either to A or either to E. Here also single pole double through, so it can throw out either to D or either to H. It's good double through, single pole double through. Here double pole double through switch, intermediate switch is double pole double through switch. How it is now, how it works? So when initially if there is any cross connection, first there are two connections in the DP/DT intermediate switch. So one is cross connection, we can connect a cross connection, another one is straight connection. First we will see the cross connection. When the intermediate switch at this connection, then what may happen? Then if it is in this connection, then in the switch 1 it is connected to A, and the switch B or SPST switch 2 is connected to D. So we have to check now whether any closed path is available. So we can see here, no, because it has been cut here, so no closed path. Here if we go here, no closed path for the bulb to glow, so bulb may not glow. Once again the closed path, I mean intermediate switch is cross connected, and if you observe here, see here, so it has been connected here, phase and neutral. And if we go here, if it is connected like this, see, it has got one closed path for the bulb to glow, so no electrical disturbance, bulb will glow. Straight connection, DP/DT intermediate switch is straight connected. Then if you see, observe this connection of SP/DT switches, so one is connected to A and one is connected to Y. Now, so if you observe closely, if you go trace the path, yes, it has been cut here, no further movement here. Once again it has been cut here, so there is no closed path for the current to flow. There is no phase neutral connection, so lamp will not glow. So if you once again if you observe DP/DT intermediate switch straight connection, second connection. So if you see the bulb will glow now. So how from phase A, B, C, D, Y and once again through N, so it has got a closed path, so bulb will glow. So if you want, you can try this also. The bulb will glow because it has got closed connection. Wherever there is a close connection with the connection of the switch, the lamp will glow. So this is the another connection, so bulb may not glow. So the tabular representation, so three-way control of lamp, it can be done like this. Switch 1 is at position A, switch 3, so B, C and F, G are closed. D, then connection will be like this, the lamp will be on. If switch is at A position, so off, is off, this is on, that you can check.